Hi, today I'm going to talk about everything I learned about using the WeCreat automatic pass-through with my WeCreat Vision laser cutter. Hi, welcome to Gray Lightning, my video blog about making things and playing games. And recently I did a video about making a scale model for Dungeons and Dragons that I can store flat. And of course that takes up a lot less space if you can store it flat. And the way I was able to do that is I put living hinges in the corners of the building, and I combined multiple walls into a single piece that you could fold, clip, play with, and then disassemble and store flat. Now that approach required that I was cutting pieces that were multiple walls long and were 24 inches in length. And by my standards, that's a relatively long piece. It would not fit in my WeCreat Vision, which is my favorite laser cutter, especially for scale models because it does such a clean cut. So what I had to do for that project is I had to go to my CO2 laser and cut it there where it would fit in the bed. And I mentioned in the video that that's what I had to do. And WeCreat saw that, and they were nice enough to send me one of their automatic pass-through systems to test out. And that's what I've been doing for the last week. I can tell you in summary up front, I'm very impressed with it. It really performed well for me. I've got two projects I'm going to be showing you here. One is this test piece for a wooden border I'm going to be making for surrounding my fireplace, and this beach house sign here, and I'll be showing both of those in this video. So I had heard about automatic pass-throughs. Of course, I know about pass-throughs in general because I have them on my CO2 laser cutter over here, but that's for a manual pass-through process. And you use it in conjunction with, in my case, Lightburn's print and cut capability. And the way that works is when you're doing a drawing that's too big for the bed, you have to plan in advance chunks that will fit into the bed at one time. And you break the drawing into those pieces. And then for each one of those pieces, you have to have 2 registration marks. And then when you're physically running the job, you have to manually move the board through for each of those cut sections. And you have to manually line up the laser head accurately on those 2 registration points for each of those sections. And any deviation, any problem with calibration you might have on the laser cutter will end up meaning that these pieces that you cut in separate passes will not actually match up perfectly. So it's more manual, more work, and it's more prone to accuracy errors. So an automatic pass-through is very interesting to me. Before I got this, I had seen a video once of someone who had a little conveyor belt that was running under their laser engraver, and they were throwing metal blanks on it, and it was running through, and it was doing batch processing and engraving. And for some reason, originally what I thought is it was something like that. But of course, when you think about that, that only works for laser engravers only. It does not work in a cutting system. Anytime you want it to cut through wood, which to me a machine isn't useful, given the kinds of projects I do, it's only useful because it cuts and engraves. So if you were cutting on that, you'd be cutting through the conveyor belt, so that's not going to work. So the solution that companies like WeCreat have come up with is a feeder system like this. And the way the feeder works is that it has a series of rollers on the top and the bottom. You feed the board in, you tighten it down, and those rollers move the board in and out, in through the back and out of the laser cutter while you're running your job. And that means a couple of things. One is this has to be a highly accurate device because it's got as much impact on the accuracy of the cut and the design and the engraving and how everything matches up as the laser cutter itself does. So this is really a very precise instrument. The other thing it means, though, is that the board you're cutting has to stay in contact with these rollers throughout the whole process. Even if it starts successfully and it starts moving through this way, if it runs out and loses contact with these rollers, the job will fail. And I know that because the very first one I tried to run did exactly that. So what I learned was you have to have enough board that you can cut your job and still have a piece here long enough to stay in contact with those rollers at all times. And you'll see this job running. That's the back of that little beach sign that I'm going to show you. And this is maximum usage of this board. When this ran, it was so close to the end here, I thought it was going to fail, but it didn't. I'll show you that in the video. But it ends up being a perfect measurement of what you need here to make your job run successfully, and that's 9 inches of extra material. So if you have to cut out something of any given length, you have to add 9 inches to it to then go look for the materials you're going to use to cut that project. One question I had in my mind is, could I use this like I normally use it while this was all set up? And the answer to that is yes. This fits underneath the laser cutter. The place where the wood is being processed is lower than your normal bed is. And you remove that bed, and when this is set up, it's plugged into the plug that the rotary would plug into. That's how it gets its power and instructions. And it has its own set of slats underneath that the wood rests on when it is inside the machine. So all you need to do to use this then as a normal laser cutter is in the WeCreat Make It software, you have a set of options right at the top of, do you want laser flat? Do you want rotary? Do you want the pass-through? You have to pick pass-through to make this run. If you do that, when it autofocuses, it's smart enough to know that that head needs to go down further to find the material. If you say that you want to run it as laser flat, you put your normal beds back in, you have it set on laser flat, it now knows that the wood that it's going to be autofocusing on is going to be at that location. So you really can switch back and forth between the two using the software. Let's talk a little bit about assembly, because there is some assembly that needs to be done when it arrives. And I did it myself. The only thing I needed help for is I did need help moving the machine onto it after it was assembled. The only things I would say about it, there are good videos online that you can see, one of which is by WeCreat. And you need really good lighting, especially when you're my age, because you have to line up some holes that are kind of down and inside, and you need good light to be able to see that, but it's not at all difficult to do. Actually, the hardest thing is that you have to find a space where you can assemble the frame that's under the machine here, which is bigger than the machine, and holds this feeder, because those are actually bolted together. So, you know, in my shop, I have a lot of rolling tables for assembly and different kinds of work and holding equipment and stuff. And they're almost all 24 by 48 inch tops. Certainly 24 inch depth is standard. And that, you know, the machine, the WeCreat Vision itself, easily fits on a table like that. But the feeder here is 28 inches wide, and it has to attach to this. And that means one of those tables, a table like this white one here underneath, was not big enough for setup. I had to use this larger table here to do the assembly. So make sure you have enough space to do that. Think about where you're going to put it while you're running it. You can see in my case, I've used one of those smaller tables to hold the extension rails, and that works fine. But you have to think about the space. But other than that, it was very straightforward assembly. I needed help to sit it on top of the frame, and then all you do is plug the plug into the rotary plug, and everything else just works. Once I realized that I was going to have to add 9 inches to any design that I was cutting to be successful, I realized that the boards that I had bought in advance for my tests weren't going to work. So I went out into the real world instead of Amazon, which is where I normally buy stuff from. And I went looking for wood, and I found a Rockler store that had 1/8 inch Baltic birch, 30-inch by 30-inch pieces, which I then used a small handheld circular saw to rip in half into 15-inch pieces, and the 15-inch pieces will fit in here. And that's what I used for this beach sign here. The other thing I discovered at my local Lowe's store is 1/4 inch 6mm poplar, solid poplar. And I didn't know if the machine, this is a 20-watt machine, I didn't know if it could cut through it or not. But it turns out that it can easily cut through it in a single pass at 100% power, 4 millimeters per second. And so that's what I used for this stained glass rose border design that I've got mitered boards of this designed to frame my fireplace. So that's done in the poplar. One other thing that you have to keep in mind when you're using an automatic feeder is that you don't want the pieces that you cut out to start tipping, as they will when they're cut loose, or falling or whatever, because the board's going to continue to be moving back and forth. And if that happens, it could interfere with the feeder. It could hit the sides of the machine itself as it's trying to pass back and forth through, and the job would fail. So the solution to that is in the WeCreat software. Based on what version of it you might have installed, it'll have something called make breaks or add breaks or perforate line. Both just different wording to say the same thing, which is that if you turn that on, it will not cut a complete line. It will put little connectors in along the way that will act like a perforation that allows you to then easily pop them out after it's been cut. That's what I did for this sign here, where I have a lot of cutout pieces, and it worked beautifully. So I'll show you that on these projects. Let's start with the stained glass rose border. I did a project about a year ago where I got these images working with ChatGPT. I painted them and I put on several coats of triple thick clear glaze, and they ended up looking just like ceramic, and I love it. I used the same techniques to get this rose border image, and I also asked ChatGPT to generate one for a corner, and this is what it gave me. I used these images to create this border to go around my fireplace. These are mitered boards here, the two of them for one corner, a matching set for the other side, and together they'll frame my fireplace. I wanted a test piece though for this video, so I did a 24-inch length. I'm cutting this out of a 6-inch wide board, so I have to move the two roller conveyor rails to the center, 6 inches apart. There's a sensor in this roller here, that's the line that you see that shows how tightly you're tightening the rollers down. The long line means it's at the highest pressure. That's what's recommended for a 6mm board, and you can see how cleanly the 20-watt is able to cut this. Before you cut anything on the automatic pass-through, you're supposed to run a framing, and that's what it's running right now on this board, and it shows you exactly where the project is going to be placed. This design is made up of many different copies of that single rose you saw from the ChatGPT. Even though those have all been grouped together, the software is executing them in its own order that I can't really tell you what the basis of it is. But here you see two of those motifs coming together, and they're coming together perfectly. This is the first demonstration of how accurate this pass-through is. It's just done another rose, and it's making the connection now between that piece of the border and the next. It's doing a beautiful job, but there's a little piece missing of the vine there up in the middle. That's because in the drawing it didn't get grouped in with those roses. Here's another motif that's connecting. It connects perfectly. And its vine in the middle is intact. A few minutes later, the software decides it's time to come back and fill in that missing bit of vine in the middle that was just loose in the drawing and not attached to any of the rose motifs. We're getting close now here to the end. You can see that the design at this point extends beyond both sides of the machine. Now we're putting in the final border edges. When this completes, it'll start the cut. It starts the cut in the middle of the long edge on the back. So I went back there to look and make sure that it's really cutting through the board, and it is. You can see that the laser is going all the way through and hitting the tray in the bottom. Here it is finishing the second short side. It'll turn the corner and head back. When it finishes, you turn the crank on the feeder and it pops out the board. And it had cut cleanly everywhere except for a small part here in the front. And you can see that's because there isn't a perfect match between the beginning and the ending of the cut line. I think this is because the board only had connection to 3 of the rollers. For my final project, I'm going to glue 2 of those boards together for a 12-inch width and make sure that they have maximum roller contact. I think that'll solve this issue. But I sanded that edge, and I think this still turned out beautifully. I'm very pleased with it. So now we're going to go to the beach house sign, which uses 15-inch boards. Once again, I used ChatGPT, and I've developed a method where I can give it a motif, and it gives me back a silhouette that I can use for laser cutting and a painted version that I can use for guiding my painting. Now, if you've worked with AI, you know it's hard to get that kind of consistency out of AI. This is the prompt I've developed that gives very consistent results, and I'll try to remember to put a copy of this in the description so you can try it if you'd like to. In my drawing, I have a page that just has motifs on it that are created by image tracing those silhouettes. The blue lines are cut lines I just changed to engraving lines. I found a font I liked and I cut it out so that the color behind this board will show through those holes. And then I drew the backing board, and the blue engraved line is where the grateful sign is going to be placed, and the color underneath is going to shine through the letters. Then I just played around with the motifs and placed them and sized them, and when I got what I wanted, I'm going to copy and paste those onto a cut sheet. Of course, the cut sheet has to have the red and blue version that will actually drive the cutting and the engraving on the laser cutter. So that's what this is here. So I actually cut these on a 12 by 12 sheet inside the normal part of the laser cutter as laser flat. I normally work with basswood, and I haven't cut birch on this, so I used the recommended settings. And while that had worked on a small test, it didn't work here, so I ended up reducing the speed to 5 millimeters per second. I needed to adjust my conveyor rails to be wider to support my 15-inch board. And you also have to do that in the back. These 2 rails also have to match the spacing of the front rails. You can only cut about 14.5 inches inside the machine, but 15 inches is perfect. It engages all of the rollers. The recommended pressure for an 1/8 inch plywood is medium, and that's what is showing in that foot there. This is what the Make It software looks like when you've selected Auto Pass-Through. You position your piece on the board, you set your speeds, and then you say framing. And then it shows you where it's going to go on the board. But in this case, it's going to disconnect from the rollers. You can see that the rollers are just spinning there, and what that means is it can't move the board back. So I canceled the job, and I knew technically it should fit because I know the dimensions of these things, but I had to be a lot more aggressive on my placement, so I moved it right to the edge. And this time the framing worked, and I could send the job to the Vision. And this is how it worked the second time. It's coming to the end of cutting the board, and it stops. Here it is. It's doing the end part of the board, so this is as far as it needs to go. And if you see where it is on the rollers, it's amazing that it even was able to pull it back out. It wasn't my intention to create the ultimate test piece, but that's what I ended up with. It let me measure exactly how much additional space you need to add, which is 9 inches. To add breakpoints, you select a cut line, you turn on the add breakpoints or perforated line option. It asks for a number of breakpoints. I didn't know, I said 20, but I cut the size in half to 0.2. But those choices seemed to work because everything stayed in place except this one little piece by the E fell out. And luckily that didn't interfere with anything, so the job finished successfully. The 0.2 number made these very easy to punch out. Here's the finished parts, and these are ready to paint and assemble. So there you have it, the WeCreat Vision running with the WeCreat automatic pass-through system. I'm very impressed with the quality of the equipment, with the accuracy of what it can produce. And I'm not really surprised because I have been so impressed with this machine that I've been using now for 2 years. So I'm really grateful that WeCreat allowed me to test the system, and I plan on using it very productively in the future.